and I'm going to come back to the project that we were working in before. So now I want to create a new level to store some of this stuff, okay? So I'm going to kind of say that, okay, we're done with this stuff for the time being. I want to create a new scene. So I'll go to my scenes folder, and in the create menu, you're going to see a scene option just down here. I'll create a new scene, I'm going to call it Space Game. And I can just open it up. This might ask you to save your current level. That's absolutely fine. So we start off just like we do in an empty project. We have our main camera in the scene, and that's it. We have nothing else. So we want to start to build this stuff out. So the first thing we're going to do is set up our player character, which is our spaceship. So we're going to do the visual side first, and then we're going to get our actual, coding done. So I want my UFO. So this UFO is going to be animated. So I'm going to have to select all of these frames here. It seems like it bleeds a little bit when it's imported in. That might be something I can change in the texture settings. So I'm going to drag this guy in, and we're going to have to create a new animation here. So I'm going to say ship idle. Okay, this is just my ship. There you go, done. So let's test this out. Yeah. So you're like, oh, that is way too small, because it is a little bit small. I can scale it up a little bit there. Okay, that's a lot better. So that is my player, fully brought in. So we got our sprite renderer, remember for drawing our sprite. We got our animator, remember, is just saying, hey, what animation is it playing? And we can go in there, we can change that as well. We want to add in a few more bits here. So I want a circle collider on this guy. So it's a circular ship. I want a circular collider. We can see that it is perfectly mapped onto it. I then also want a rigid body. And we can leave all the defaults there then as well. And I think our player is nearly ready to go. So I want to click on play first just to test something. And there we go. So not much point having a space game if our character is just going to fall off the screen. So remember all the way back to our first kind of videos, we had in our rigid body a gravity scale that we can tweak. And we actually did tweak it. So I'm going to set this guy to be 0. And now when I click on play, my ship isn't going to fall. Okay, it's in 0 gravity. All right, perfect. So that is our player ready to get programmed. So we're going to create another folder, and I'm just going to call it scripts. Just note that, oh, I didn't mean to create a new script. I meant to create a folder called scripts. So I'm going to delete this guy. And we'll call it scripts. And scripts are just classes. Okay, that's just what Unity's way of calling it. So each one of these scripts, so I'm going to create a C# script, is going to represent something for our game. So we did talk about creating classes for each individual object, like a cat and that kind of stuff, as one single class. In games, though, like in Unity and Unreal Engine, we'd like to split things up into be a little bit more reusable. So for my player here, I might create a class that just handles movement. I might have another class that just handles collisions with stuff. I might have another class that just handles shooting projectiles. And that means I can reuse this stuff, turn stuff on and off, and it makes our life easier. We don't have big lumps of code that do everything. We're just going to have small bits of code that do very specific things for us. So starting off with the player, we do want to get moving pretty quickly. So I'm actually going to call this script player movement. And I realize that's probably pretty hard to see. So, player movement. So that has added in. We can click on it here. We'll see that it gives us a little preview of the code that's already been added into it. What we want to do first, though, is we're going to come back to my UFO. I'm going to change the name to player. If you remember, we have our tags here then as well. And Unity actually has them built in for us. We can just add player. That's my player setup. And now I want to add on that little bit of code that we written. So we can see player movement here. You can either drag it up and you see the little blue line pop up, or you can actually just click on add component and then type in, there's my player movement. And that's it. That is the code added. So if you click on play, again, absolutely nothing happens. All right, it's not going to do anything for us. We're going to have to go in and now edit this. So I'm going to double click on the file. It's going to start Visual Studio, so you may have to wait a couple of seconds. If it's your first time running it, it'll ask you some questions about what color you want to pick and what other kind of styles you want. So hopefully you can see this in the dark theme that I've laid out here. I have blown it up quite large, obviously, so we can kind of see it easily. So this script I've created, if you remember back to when I was writing that in my notepad, I had class player movement. Now there's a few additions here. You're going to say that public means it's visible so we can actually see it. Mono behavior, I talked about this guy. This is where we are inheriting from this guy. So this is a part of Unity, and anytime we want to add on a script that is going to be attached to a game object, we're going to have to use this. Okay, so there's like rules here. You want to write code that you're going to attach to a game object in Unity, well, you're going to have to inherit from this. And inheritance works just like it does in the real life. You gain stuff from your parents or whoever comes before you. So in this, I may have a class called animal that has stuff like weight and age. I could then have cat inherit from animal, and it will gain the weight and the age for free, and then we can add in cat specific stuff. Same goes for dog. Dog could then inherit from animal, add in its specific stuff. Same goes for monkey. Monkey would add in all its specifics. And then you just have the one base class. They're all animals, and we could change stuff in animal and it would be reflected in all the children then as well. Same idea. We're also notice that we start off with two methods. And I know it's a method because it has a return type, it has a name, and then it has the two round braces and my two curly braces here. So these are built-in ones in Unity. So as it says here, start is called before the first frame update. So as you click play, this object is in the level. This is the first, or actually it's one of the first methods that is called to us that we can see here. These are our comments, the two slashes, and then the green text. I'm going to remove that. Same for this one. So do note, in the start method, anything in between these two curly braces, as I mentioned before, is going to get executed every time this is called. We have our update, and this is where the brain of your game is going to be. So this will be called whatever, 60 times, 30 times a second, whatever you require into it. And these two are called externally, so we don't have to call these. Unity does it for us. So if I want to be checking, oh, how close is an enemy from me and how many bullets do I have? Should I shoot it? This is probably where you'll start to implement that kind of logic inside in your update. So let's think about our player. Get back to doing our own coding here. How fast are we going to move? This is really our key bit for our movement. So I want this to be stored as a floating point number, which is what we're going to have to use in Unity. I might call it speed. And we can give it a starting value. Let's say something like 10. 10 is probably huge, okay? But I'm going to give it a starting value of 10. Now, a really nice thing about Unity is, if I go back in over here for a second, just to note, when you actually make code changes in Unity, to the very, very bottom right-hand corner, you won't see it now, but right down here, you'll see a little loading symbol. That means it's compiling your code in behind the scenes, and you typically wait until that is finished before you go do anything. Otherwise, it's just going to be laggy and feel like something's broken. Yeah, so let me go back to my player. I have that script assigned to it. Oh, I added on that speed variable, but I'm not seeing it here show up whatsoever. So if you remember back when I did my class first, I just had class cat, and I notice here that public's been put in, and as I said before, that means we can see it. So I wonder if I put public in front of a variable here in Unity, is it going to make it visible to me? And of course it is. So I can come in here, I can change my speed value. I can even do it while the game is running, and it gives you just a little bit more control that you may not necessarily have through code, or you would have. You have the exact same. Sorry, what I'm saying, you have the exact same control through code, but it might be a little bit longer to do. And you have to come over here. You have to change a value. You have to go back in, wait for it to compile. You then have to go test it, as opposed to just changing the value directly from within Unity. So this is something that we want to be able to see. So public. Think about visibility. It means other objects inside Unity can also see this. So we could actually change the speed of this object. You could have black holes or something that slow you down as you pass through them. And you can handle that easily enough. So in Unity then, movement. So we kind of talked a little bit about how this is a 2D game. So we have an X and a Y axis. So your X axis is your horizontal, your Y is your vertical axis. When we're taking inputs in, we're going to be moving on the X and the Y axis. So I'm going to create two variables to store where we're going to be moving, basically. So these are going to be floating point event numbers. One's going to be called horizontal. They're going to have another called vertical. And I'm not going to give them any starting values at all. So the thing about this is what I'm going to do is I'm going to ask, hey, what keys are pressed? So if the A key is pressed or the D key is pressed, well, I'm going to store that value in my horizontal variable. If they press the W key or the S key, I'm going to store that in my vertical. Okay, so we're going to be reading inputs from the user and then storing them in a variable, and then we're going to use that to move later. Okay, so we want to do a little bit of input here. So Unity, thankfully, let me just see here, I think it's in project settings, provides what is known as the input manager. And basically what they've done here is they've set up inputs with kind of friendly names. So they've mapped a load of buttons, so the left and the right key, to a name called horizontal. They've done the same with vertical, so they've mapped my down and up arrows and my S and W keys. They are all fully mapped on. And of course, there's a few more down here for different inputs then as well. So that is from your joystick. So your Xbox controller, your PlayStation controller will work straight away here. And they're all mapped. So just look at them here. We have name, and then we have what keys are assigned to it. So I have a horizontal axis. It's assigned to my left, right, A and D keys, and we can ignore the other kind of bits of information here. There's also a vertical one, so it's mapped for these here. That means I can actually ask Unity, hey, what's the value of vertical or what's the value of horizontal? So I can specify these two names. It'll then check, hey, well, are any of these keys pressed? And if they are, we'll then return a value back. We're going to notice then here as well that they have what these call positive and negative values. So if I'm looking at the horizontal axis, they're saying left is a negative button and right is a positive button. And what that means is the value that's returned from this is actually going to be a positive value. So a +1 if it's going to go right, and the negative value will be -1. And the same goes for the vertical. If I press the W key, Unity returns back, hey, here's a +1. And if they went down, here's a -1. So that's just to indicate what kind of direction, or is this a positive or negative action that the user is kind of completing. So basically, hey, tell me what is the player moving left or right? Unity returns back -1 or 1, depending on what's actually going on, or 0 if there's nothing. So if we want to get this information, it's actually stored to a class that Unity provide called input. And I can say input.getAccess. Now there's actually, well, we'll mess around here first. We'll let it go through here. So get access, I can see then it actually pops up some information for me. That's going to disappear. Oh no, I thought it was going to disappear as soon as I pressed control, and it did. It actually says here, it returns back a float, which is very difficult to see. And what it wants is a string called access name. So give me the name of the access that you want, and I'll return back a floating point number to you. So I mentioned way back when I was looking at variables that you want to do a string is 2 double quotes. And all I got to do is spell the name horizontal exactly as it had showed up in Unity under that kind of project settings window. Remember, I had a horizontal, there's the name, you can even copy it out of it, and there's my vertical then as well. So input get access horizontal, that's going to return back -1, a 0, or a +1, or a +1, it'll just be 1. So I can see if I hover over here, it returns back a float. I need to do something with it. I need to put it somewhere. So I put it in a horizontal. So let's say my horizontal is equals to input.getAccess. Now I knew that this guy was going to return a float, but say for instance, what if I didn't? What if I had string put in here? It's going to complain. All right, it's going to let you know that you have the incorrect data type. Now you can do conversions and that kind of stuff, but we do want to have a float, obviously. That's the value that we want. So for our next one, we can see that, hey, we're going to have a vertical as well. So let's grab that guy. So input.getAccess, and we're going to put in our vertical. So now, every single update of the game, every single frame, I am now reading in the horizontal and the vertical values. So what we could do here, if I just make both of these public, and then we're going to go over into Unity and we're going to see these values. I'll make them back private again, though. We don't want to actually be able to edit these inside in Unity. We just want to be able to preview this a little bit. So we're going to keep an eye. It might be hard to see on my horizontal and my vertical guys down here. And of course I have my on-screen keyboard thing as well, so you'll see what key I'm pressing as I'm doing it. So if I press the left key, we can see that it's moved to -1. If I press the right key, it goes to 1. Same with my W, same with my S. And we're going to notice there's actually a bit of an acceleration as we go. So it's not instant. There's an acceleration going on here, and we can change that if we like. So I might come back, if you wanted to make sure that it was instant acceleration and you're just immediately kind of zapping and flying around the place, there's a get access raw that we can use, and we might use it later. We'll see how this guy moves around once we're in it. Okay, so that's it. We've read input from the user. So what next we want to do? We want to take that input and we want to translate it into actual physical movement within the game. So we have two options. And one is we're really only going to use one of them. But we do have at the top here a transform component that holds the position of my player. Now, a very, very useful thing in Unity is accessing this transform. I can say transform dot, and I've access to everything, my position, my rotation, and my scale. The only problem with this is if we're using the physics system, it's actually calculating where we're going to be, what our position is, what our rotation is, all that kind of stuff for us. So once you start using rigid bodies, we're not really going to be able to move stuff around because you're just going to pass through objects, or you're just going to get really unexpected results out of it. So we are going to come back to this guy at some point to move stuff around, but right now we're going to have to focus on a rigid body. So we want to move this guy, and we have a few options. You can kind of do it the fancy way of adding velocity and adding forces to the guy and pushing it around, or we're just going to say, hey, I want you to move here, and that's exactly the way that we're going to go about it. So I actually need access to this rigid body. So if I want to move this guy around in code, I need some way to get the rigid body that's attached to the game object. Okay, remember the player movement here is a completely separate thing by itself. The rigid body is by itself, the collider is by itself. We need to do a little bit of communication from our script. We need to go in and get that rigid body, and we need to tell it to move. So if we're going to go in and we're going to retrieve something out, I actually want to store it in a variable. I'm going to remove those two publics here as well. So I'm going to create a rigid body 2D, and we're just going to give it a name. It's called a body. So now we have a variable here, and we know it has a different color because it isn't a built-in type to the language. So float, int, string, all those kind of guys are built in. Rigid body 2 here is actually a part of Unity, so it's going to show up a little bit different. So we're actually going to have to get this guy, and we're going to have to fill it in. Now this script that we have here, player movement, is attached to a game object that has a rigid body. So if we're attached to the exact same game object, I can actually communicate or find other components that are there. This guy here called get component. And we're going to have to just skip over the syntax here. You think that this is a method, and the method is going to take a parameter, and that parameter is the type of component that I'm trying to get back out. So I'm looking for a rigid body 2D. So I put in rigid body 2D, it goes into the game object, and then it starts to look for a rigid body 2D. So it's going to find this guy. But you know what, I can put in loads of different stuff here. I can put in sprite renderer that we're using to draw stuff. If you wanted, you could put in transform, I suppose. And because we created our own script, our own kind of component, we could put a player movement in here. So if I wanted to access the player movement from a black hole, as I said before, I could do that, and I could change the speed then through this. But I want to put this guy back to my rigid body. So that guy's actually going to go into the game object, find the rigid body, return it back out, and then we're going to have to do something with it. So I'm storing it in my variable here. Now, one thing to note, if I actually took that rigid body guy down here and put it inside my start method, you think, okay, this is going to work. It won't. If I go body here, it's not visible at all. So where you declare this variable is very, very important, because we can't have local variables. So variables that are declared inside a method, but they only exist inside that method. Okay, so you won't be able to use them externally or anything like that. Okay, so I got my rigid body, I got my input. Let's move this. So there are different places where you can put this. I think typically if I'm going to move an object with a rigid body, they want you to use what's known as a fixed update, but we're going to keep things nice and simple here. So we're just going to move it directly down here. So what do we want to do? What does my body provide me? It does have a method called move position. It also has one called move rotation that we are definitely going to be use. But let's see here my position. So moves the rigid body to a specified position. And it wants a vector 2, which is something we haven't seen yet. So in Unity, we said we have an X and a Y axis, and there's also Z1 because it is a 3D game engine. But we're working with 2D data structures here, so rigid bodies for 2D stuff. So it wants an X and a Y position. Where do you want to go? We start off, or the origin of the world is 0, 0. If you go right, it's a positive X. You go left, it's a negative X. You go up, it's a positive Y. You go down, it's a negative 1. We know that these guys are passing in what direction we want to move in. We have a speed that we're also provided with, and we can actually access our current position if we want then as well. So if I want to move a little bit to the right of where I am, I just need to know where I currently am and by how much I want to move. So it sounds, oh Jesus, what the hell is he talking about? It's actually going to be really, really straightforward here. So we're going to move position. So where are we going to go? That's basically what it wants to know here. So if I come in here and I say new, what it's actually going to try and prompt me here is, hey, you want to create a new variable, a new vector 2 of where you want to go. So this actually could be quite long. So my X position is really going to be my current position. So transform dot position dot X. Remember, these are all objects. So a transform class has been written somewhere. It's attached onto this game object with player movement. It has a variable, just like the guys up here, called position. And then that variable has another, what we call a property or variable inside it. That is its X value. And you can even see there's a few different ones in here. .x, .y, there's .z, and it actually has actions, methods that can be executed then as well. But I'm just going to say, hey, get my current X position. And I want you to add a little bit onto it. So what do I want to move by? I want to move by, say, my speed multiplied my horizontal, because that's my x-axis. And we're going to test this. If you've ever done programming in Unity, you're probably already screaming because there's multiple things that we can clean up here, but remember, we want to keep it nice and simple. So let's see what happens. Does that actually happen? And I go flowing off the screen, but I'm back. So speed, way too big. Okay, so let's go in and see, all right, how do we fix this up a little bit? So I know my horizontal is working. One thing I'm going to note is I'm supposed to be creating a new variable 60 times a second. If you spot something that you're going to be using quite a bit, create a variable for it. And every frame, I'm just going to update and say, hey, new position, the X value of new position is now going to be equals to, assuming it lets me do this, we'll see in a second. I can, perfect. So basically I've just moved this and square. So I created a variable to store where I'm going to want to move next. And then saying, hey, the X value of next position is my current X position plus my speed multiplied by however much I'm going to be moving right or left. I'm going to do the same for my next position dot Y. And it's going to be pretty much the exact same code. Transform dot position dot Y plus speed multiplied by horizontal. And then the only thing I actually have to put in here is next position. So instead of me creating a new variable every single frame called next position, I'm just updating the one existing one that we have. And then that's going to be reused every frame. So let's see what's happening here. It looks like 5 is probably way too big. So I make that 1. It's probably going to be really small. Oh. I put in the wrong one. That's supposed to be vertical. If I'm moving vertically on the y-axis, not horizontal. There we go. And we're moving around the screen. Still way too fast. So if I come in here and I say next position, I just want to see what happens here. If I go time.delta time, now I'll come back and I'll explain what this is in just a second. But this should... kind of freaking out. know what, we're just going to leave it. And we'll see how much smaller we can make it. Okay, that's a bit better. So 0.25, that's my speed. And I'm able to move around. Okay. So we can change this by using delta time, and then we can kind of keep fairly similar numbers to what we had before, but we'll just keep it nice and simple. So I got my spaceship moving around. Excellent. Maybe we will have a go at doing our rotations here. So I want my ship to be spinning continuously. So I'm just going to do this down here. So I'm going to add a public float up the top here. I'm going to call it rotation amount. How much do I want to rotate every single frame? Now I have this put down as 1 degree. And I've seen in here that there was a move rotation. Rotates the rigid body to angle. So we'll just do an okay. Can I get my body dot rotation? I can. If I do body rotation plus rotation amount, just to see what happens here. It'll probably go spinning. No, it's working okay. So now we have, and we look up the top here. I can see my values. Oh, and of course it froze it as I did it. But these values are changing. So as your rigid body has been moved around, it is going into the physics, doing its simulation, and then coming back and updating our position. And then it's doing the same with my rotation. I can see my z-axis is changing as the ship rotates. Okay. And that is our first bit of programming done. And it's actually quite a bit there. That's a lot of information. So take your time maybe to go back and make sure it's kind of sinking in a little bit. We just have a class called movement. It goes, get some input from the user. We then use that multiplied by speed and use our rigid body to be able to move around. And that's it. We got our player movement pretty much ready to go.